Alright, I'm going to go through the test review here for the test tomorrow. And basically, to find circumference of any circle, you take 2 times pi times the radius. Well, in number 1 and 2, the radius is given as 9. So for number 1, your circumference will be 2 times pi times 9. Which is 57 if you round it. Number 2 is done the same way. Let's move on to number 3. In number 3, I have given you or provided the circumference to you. So what you need to do is you need to divide this number by the radius will equal this number divided by 6.28, or the number divided by 2 times pi. If you use the 2 pi, remember you must use parentheses in order to get the correct answer. And that answer, R, should be 12. Alright, number 5. What we're doing in these problems is they want the measure of HJ, which, if you go this way, it's a little bit of confusion as to which way to go, but usually you're supposed to go the shorter way, I believe. Basically, what I would do to solve this problem is, if I look at this line here, then this half of the circle is 180 degrees. If I subtract the green arc from 180, that will leave me with the HJ arc, which is what I'm looking for as the answer. And that answer then is 140. For number 6, doing very similar work. What they want is angle. This time they want an angle, RQT. Well, that's this angle here. So basically, this angle measure is 67 plus 56, because the arc that's across from the angle is the same as the angle measure. And that's 123. Number 7, this time they want measure of GE. Well, GE is this angle measure here, which is 140, because I'm adding up the 100 and the 40. That's 100 plus 40. Number 8. Now, number 8 is the hardest part of the test, 8 through 14. What you need to do for these problems is, this is from section 9-6, so you need to use your study guide. And you want to remember there's 3 different theorems on that study guide. The first theorem covered if 2 lines crossed on the outside of a circle, which they do here. Then to find the angle measure, okay, you take the big arc, which is the blue arc here, which is our x, minus, and you subtract the small arc, okay, and then you divide that sum by 2. And then what you do is, to solve this, you're going to multiply by 2 on both sides. That's 80 equals x minus 74, and then you're going to add 74. X equals 154. So you set up number 9 the same way. You have the angle here, which is 45. There's the big arc, which is x, and the little arc is 48, so it's x minus 48 over 2. Multiply by 2 on both sides, you're going to get 90 equals x minus 48, and then you're going to add 48. So x is 138. I'm subtracting the arcs because the lines cross on the outside of the circle. That's where they meet. So for number 10, I'm doing the same problem, but the algebra is more difficult because I still have an angle here, which is equal to big arc, which is the 4 plus 32, minus the little arc, which is 84. You still divide that by 2. So the setup is the same as in number 8 and number 9, but this time my algebra is harder because I'm using equations instead of just numbers. Here you would combine like terms, 4 minus 84. So I have, you're going to multiply by 2. Multiply by 2. I have 18x minus 10 equals 32x minus 80. And then you solve the rest of the equation. You get x is 5. Now number 11 is also from section 9-6, but this time the two lines meet on the circle. And when the two lines meet on the circle, you take the arc that they provide you, or if the arc's not provided, you divide whatever that arc is by 2. So it's actually a simpler problem because you're not adding or subtracting arcs. So when you divide this by 2, you're still going to multiply by 2 first on the right to get rid of it, and then you're multiplying by 2 on the left. It's 120 equals 10x plus 10, and x will end up being 11 when you solve the rest of the equation. Now number 12 comes from section 9-7. So the next section covered the segment lengths of secants and tangents. Okay? And when we're doing segment lengths and we have two lines that meet outside, then you want to set up the equations by using the outside of one line times the total length of the line. Okay? And when you have a secant and a tangent, then what you want to do is you take the tangent line and you just square it. So this is 81 plus 9x equals 15 squared is 225. You want to subtract 81. And you're going to get 9x equals 144, and then when you divide by 9 you get x equals 16. Okay, so that's tangent line, which is my green line, and secant line is my red line. The tangent line is squared and the secant line is set up by multiplying the outside times the total. In 13 we have two secant lines. We don't have a tangent line. So we take again the outside part of the line times the total part of the line equals the outside part of this line times the total. Well, 6 plus 4 is 10. So again, you distribute here. That's 25 plus 5x equals 40. Subtract 25. 5x will equal 15. X will equal 3. In number 14, now we have two secant lines that cross on the inside of a circle. So what you do there is you take each part of the line, each part of the secant line, and multiply it together. Again, you distribute. You want to subtract 14x, 2x, add 32. That's 18. Divide that by 2, x is 9. So again, when the lines cross on the inside of the circle, then you multiply each part of the segment together. Now for 15 and 16, it's the same type of problem. So I'm just going to do 15 here. My center comes from the opposite of this number and the opposite of this number. So my center is 3, negative 2. Okay? That's here. And my radius is the square.